Hey guys, welcome back to a new video. In this session, we are going to be looking at derivatives with multiplication. This means taking the derivative of a product of two functions. As always, these exercises will start out very basic, but will get progressively more difficult along the way. So feel free to skip around according to your own level. The timestamps can be found in the comment section below this video. Before we go to the exercises, let me just take a minute to look at the general formula for the derivative of a product of two functions. Here you see the derivative of the product of two functions. F of x is a first function and g of x is a second function. It is very straightforward to take the derivative of this product. And it's important to realize that it's not just the product of the derivatives of each function separately. Rather, it's this form. First, you take the derivative of the first function and you leave the second function untouched. Then you leave the first function untouched and you take the derivative of the second function. In this way, if you do your calculations correctly, you will always get the right result. So with that out of the way, let's go to the first exercise. The first exercise is the derivative, d of dx, of the product of x times x squared. Now at this point you might object that x times x squared is just x to the power of 3, of which you know the derivative by heart. However, I want to start with this basic exercise by just showing you that this general formula actually works. The first thing to do in these exercises is to identify the two functions that are multiplied by each other. So let's do that in this one. So this is d over dx of the first function is x and the second function is x squared. And now we have identified our two functions, so we can just use the general formula, which is equal to d over dx of the first function, which is just x in our case, times the second function, which we leave untouched. Plus, now we leave the first function untouched, which is x, and we multiply this by the derivative of the second function, which in this case is just x squared. Writing this, we get the derivative of x is just 1 times this untouched function, which is x squared, plus x, which we leave untouched, times the derivative of x squared, which is just 2 times x. And if you're having trouble with derivatives of powers of x, I can point you to my other video where I do step-by-step exercises on derivatives of powers of x. So we got our result. Our result is basically x squared plus 2 times x squared, which is equal to 3 times x squared. At this point, it might be clear why I used such a trivial example to begin with, because we can very easily check our result. As you might have seen from the beginning, this x times x squared is simply x to the power of 3. And we know the derivative of x of the power of 3. It is just 3 times x to the power of 2, because this 3 gets in front, it drops down, and the power gets subtracted by 1. And we see that we indeed have the same result, so our general formula holds. Let's now go to the next exercise, which is d of dx, the derivative, of x times the ln of x, so the natural logarithm. As always, first we determine or we identify the two functions that are multiplied in this derivative, which is quite straightforward here. So it's x as a first function times the logarithm of x as our second function. And once we've identified these two functions, it becomes very straightforward, because we just take the derivative of the first function, multiply this by the second function, which we leave untouched, plus now we leave the first function untouched, and we multiply this by the derivative of the second function, which in our case is the natural logarithm of x. This is equal to the derivative of x, which is simply 1, times this other second function, which we left untouched, the ln of x, plus our untouched function, which is x, times the derivative of ln of x, which is 1 over x. Rewriting this, we get the ln of x plus 1, since this x and this x cancels out. And we have our result right here. Let's go to the next exercise, which is the derivative, d over dx, of the square root of x times e to the power of x. And again, the first step is to identify our two functions which are multiplied. The first one is square root of x, and the second one is e to the power of x. And now we can simply use the general formula. So we first take the derivative of the first function, which is the square root of x, and we multiply this by our second function, which we leave untouched. Plus, now we leave our first function untouched, square root of x, and we multiply this by the derivative of our second function, which is e to the power of x. Now we take these individual derivatives. So the derivative of the square root of x is simply 1 over 2 times the square root of x. And we multiply this by our function that we left unchanged, plus the square root of x, which we left unchanged, times the derivative of e to the power of x, which is simply e to the power of x. Now, at this point, our derivatives are already done. So we can leave this result as is, or we can just rewrite this a bit and somehow practice on rewriting or algebraic operations. So we will try to put this on an equal denominator, right? Because here we have something in the denominator and here we don't. Basically here we have divided by 1. So we get e to the power of x divided by 2 times square root of x plus the square root of x times e to the power of x. Rewriting this, we get e to the power of x divided by 2 times the square root of x plus, so for the second term, we want it to have the same denominator as the first term, which means that this term, the square root of x times e to the power of x, we want it to be like this. However, to make this term equal to that term, we have to multiply by this 2 times square root of x, because what we actually did here, from here to here, we multiplied this by 1, and 1 can be written as 2 times square root of x divided by 2 times the square root of x. And this is this term that, well, this extra term that makes it so that now we are on the same denominator. So having this on the same denominator now means that we can rewrite it as one fraction. So you have e to the power of x plus 2 times the square root of x times the square root of x times e to the power of x divided by 2 times the square root of x. And we can rewrite this by noting that this e to the power of x is common to both terms in the enumerator. So we can write e to the power of x times 1, which is basically this term, plus 2 times x. And 2 times x comes from this 2 times square root of x times square root of x, divided by 2 times the square root of x. And this is our final result for our initial derivative, which was the derivative of square root of x times e to the power of x. Let's go to the next exercise, which is d over dx of the sine of x times the cosine of x. Again, we want to, as a first step, identify the two functions that are multiplied. So we get d over dx of our first function is the sine of x times our second function is the cosine of x. And at this point, we can just use the general formula. So we get, first, we derive our first function, the sine of x, and we leave our second function untouched, times the cosine of x. And then we do the same but for the second function, so we leave the first function untouched, and we multiply this by the derivative of the second function, which is in this case the cosine of x. And now, because we know the derivative of the cosine and the sine of x, we can just simply calculate this, which becomes the cosine of x, which is the derivative of the sine of x, times the cosine of x, plus the sine of x, which is the function that we left untouched, times minus the sine of x, which is the derivative of the cosine of x. It's very important to remember that the derivative of the cosine of x is minus the sinus of x. And we can rewrite this as the square of cosine of x minus the square of the sinus of x. And there we are, we already have our answer. The next exercise will be important if we are going to look at fractions, so derivatives of fractions, which I will leave for a future video. But at this point we can solve these exercises only by using the rule for the derivative of a product of functions. It is d over dx, so the derivative of tangent of x times 1 over x. Again, the first step is to identify our two functions that are multiplied with each other. The first function is tangent of x, and our second function is of course 1 over x. And at this point we can use the general formula again. So we get d over dx of our first function, which is the tangent of x, times 1 over x, our second function, which we leave unchanged. Plus, now we leave our first function unchanged, the tangent of x, and we multiply this by the derivative of our second function, which is 1 over x. And now we can just calculate the derivatives of our individual functions, which is 1 over the cosine squared of x, which is the derivative of the tangent of x, times 1 over x, which is our second function that we left unchanged, plus the tangent of x, which is our function that we left unchanged, times minus 1 over x squared, which is the derivative of 1 over x. Again, if you're having trouble with derivatives of powers of x, please go and visit my previous videos where I go through these exercises step by step. And now we already, have our answer. We have 1 over x times cosine squared of x minus tangent of x divided by x squared. As in a previous exercise, we can leave it like this because we did all of our derivations. However, it is a nice opportunity to practice our algebraic operations. So we can rewrite this on a common denominator. And to do this, we look at the highest power of each function in our denominators. And this might sound confusing, but let's just look at it. So here we have x squared, and here we have only an x. This means that in this denominator, we want to get x squared. And this is done by multiplying both sides, so the numerator and the denominator, by x. So we do this like this, because x divided by x is just 1. And we rewrite our denominator, which we already had. In this denominator, we have cosine squared of x, which is absent in this denominator. So we want to get it in the other denominator, in the second denominator. So again, we do cosine square of x times x squared in the denominator here. But then, of course, we have to write it as well in this numerator. So at this point, what we did was just multiply 1 to each of these denominators. Because as you can see, if we cancel these two terms, we get this fraction again. If we cancel these two terms, we get again this fraction. So we basically did nothing but rewrite it. And now because we have an equal denominator on both sides, we can take these two terms together and write it as one fraction. So we get x minus cosine squared of x times tangent of x divided by x squared cosine squared of x. And this is our final result. And it is more, well, nicely written than our previous result before we did some algebraic operations on it. Let's look at the second to last exercise, which will be a bit more difficult, but stay with me. We have d over dx of the arc tangent of x times 1 plus x squared. At this point, we first have to identify the two functions that are multiplied. And actually here there are two ways of approaching this. We could first multiply this arctangent with both of these terms between these brackets, and then use the fact that the derivative of the sum is equal to the sum of the derivatives. However, we can of course also look at this as one function. So we could also identify the following functions as our two functions are multiplied. So the first is the arctangent of x, and this one is multiplied by 1 plus x squared. And let's go ahead with this solution, because in this solution we only have to do two derivatives, which makes things more easily. This is equal to the derivative to x of our first function, which is the arctangent of x, times our second function, which we leave unchanged, which is 1 plus x squared, plus, now we leave the first function unchanged, so the arctangent of x, and we multiply this by the derivative of the second function, which is 1 plus x squared. And let's now do our individual derivatives. The derivative of the arctangent of x is actually one that you'll have to learn by heart. It is 1 divided by 1 plus x squared. And we multiply this by the function that we left unchanged, so 1 plus x squared. Plus, now we write our function that we left unchanged, so the arctangent of x, and we derive this 1 plus x squared, which is very simply 2 times x. And in short, this is d over dx of 1 plus d over dx of x squared, which is 0 plus 2x, which is 2x. These two terms very simply cancel out, and we get 1 plus arctangent of x times 2x, and this is our result. The last exercise is a special one, and it is one that if you can solve this one and you understand every step that I did along the way, you can be sure that you really understand how to solve these exercises. Because in this exercise, we're not going to make the derivative of two functions which are multiplied, but the derivative of the multiplication of three functions. So we have x times the ln of x times the sine of x. So how are we going to solve this one? Well, the first step is to identify the two functions that are multiplied with each other. However, in this case, we have three functions. However, we should not be confused by this, because what we can do is just take this one as one function and this one as the other function, and thereby having two functions which are multiplied with each other. So how does this look? Well, we have d of dx of our first function, which is x times ln of x, times our second function, which is the sine of x. And now we just use our general formula to solve this multiplication of two functions. So we have d over dx of our first function, which is x times ln of x, and we leave our second function unchanged, so it's sine of x, plus now we leave our first function unchanged, so x times ln of x, times the derivative of our second function, which is sine of x. And at this point in the previous exercises, we could just calculate the individual derivatives right away. However, in this exercise, we see that in this first term, we still have the derivative of a product of two functions. However, we know how to solve the derivative of a product of two functions. That's what we've been doing all along in this video. So let's just, again, use this as an exercise within an exercise. So we get that d over dx, we first identify our two functions, which is now x times, and our second function, I will actually use another color here, is the ln of x times, and then this one just remains unchanged. Plus, and then in the second term, we simply have the derivative of a function that we know. So we can rewrite this already. So we have x times ln of x times the cosine of x, because the derivative of the sine of x is the cosine of x. What we can do now is just use our general formula on this product of functions. So we have the derivative of our first function, d of dx of x, times our second function, which we leave untouched. However, here we have to take into account that this sine of x is multiplied by this entire term. So we have to multiply sine of x by it as well. Then plus we leave our first function unchanged and multiply by the derivative of the second function, which in this case is the ln of x. And again, we should not forget this sine of x. So times sine of x plus x times ln of x times the cosine of x, which is simply this term, which, well, remains untouched. And at this point, we can make the derivative of these individual functions. So we have d of dx of x is simply 1 times the ln of x times sine of x, which is just this term, plus x times the derivative of ln of x is 1 over x, and then times this sine function that we should not forget. And we just write this term as is because we didn't change this one for a long time. And now we have our answer, because this x and this x cancels out. This one we can just, well, drop. So our answer will be the ln of x times sine of x plus the sine of x plus x times ln of x times the cosine of x. And this is our result. We could also now take some terms together. For example, here these two are in common, or this and this one is in common, but well, I'll leave that as an exercise. And well, this is basically the result of this quite daunting looking exercise of multiplying 3 functions instead of 2. This brings us to the end of the video, and I hope that you learned something and that you now know how to solve problems where you have to take the derivative of a product of 2 or even more functions. As always, if you have any questions or are confused about something, just let me know in the comments below. I read every and single one of them, and I also answer all of them. If you have any suggestions for future content that I can make, I will almost certainly make such a video specifically on that topic. If you actually learned something and you think that more people should watch these videos, then you can always give it a like, because this makes it more likely that other people will find these videos if they search for it. And with that out of the way, I see you guys in the next video. Bye.